Now we are going to talk about the stability of carbanion. Now carbanion stability we have seen in place of R, H and I. Now we are going to see combinedly the stability of carbanion. What are the stability of carbanion? We know stability is directly proportional to electron donating group and inversely proportional to electron withdrawing group. The stability of carbanion is directly proportional to electron withdrawing group. That is reverse. Electron withdrawing group and inversely proportional to electron donating group. Now, how do we define the stability of carbocation? Serial wise. Stability is first part of aromatic system. So first of all, it should be the part of aromatic system. It is the most stable, but in the case of carbocation, it was not that part. It was the part of dancing resonance. But here, in dancing resonance doesn't occur. It only occurs in cyclopropyl carbocation, not in carbanion. Remember. Now, the second case we're gonna compare is minus M. Minus M, we have CH2 negative, then we have aldehyde. Now we have CH2 negative, then we have aldehyde. So it is minus M and it is minus I showing. So minus M are more electron withdrawing. So the stability is more in here in that case. In the third case, CH2 minus NO2. Then we have CH2 minus C double bond OH. Then we have CH2 minus C double bond OH. So it is like 1 minus M, second and third. This is minus M stronger than minus M, then minus I. Next we have the examples of minus M, cyanide group attaching over the para side of C triple bond N. Then we have cyanide attaching on the CH2 negative C triple bond N. So it is showing minus M and it is showing minus I. So which is more stable, minus M or minus I? We know that minus M stabilizes more as compared to minus I. That's we are talking about. Third we have resonance, when negative charge is involving in resonance. Third we have resonance, or we can resonance. So when negative charge is involving in resonance, it is more stabilizing. CH2 negative, CH negative. Then so between these two, it is more participating in the resonance. Next we have negative charge over here, negative charge over here, negative charge over here. Remember, here we have negative charge. So here we have resonance R here, over here R, but extent of resonance is more in that case, and here we have only plus I. Now we'll talk about next question. We have this negative charge. We have this negative charge. We have in these two, this is more stable. We have this negative charge, and we have this extent of resonance is more, this is stable. Fourth we have minus H, CH2 negative, CCl3, CH2 negative, CCl3. Next we have CH2 negative, C double bond OH. Next we have CH2 negative, CCl3. So this is the most stable, minus M, and this is minus H. This is minus H and this is minus I. So minus H is more stable as compared to minus I, but here minus M is more over that. Next we have minus I effect. Minus I effect we have negative charge, then fluorine, and fluorine is attaching further different, so this is more. Then we have CH2 negative, then we have CH2 negative, CCl3, then we have CH2 negative, CF3. So 1, 2, then 3. Because it is minus M, this is minus I, and this is also minus I. But minus I of CF3 is more as compared to CCl3. Now next we talk about hybridization. Hybridization. Hybridization we have CH3, C triple bond, C negative, CH2 double triple bond, CH negative, CH negative, CH3, CH2, CH2 negative. So one has sp hybridization, more electronegative, 1, 2, and 3. After hybridization, or we can say, yeah, after hybridization, the 7th factor that we gonna compare, this 7th factor is plus I, 8th factor is plus H, 9th factor is plus M, 10th factor is part of anti-aromatic system. So these are the 10 factors we are going to consider about the negative stability of negative charge. So let's solve some questions of carbanion, stability of carbanion. Carbanion compare. Stability of carbanion compare. First, CH2 negative, CH3. CH2 negative, CCl3. Then we have CH2 negative, then CCl3. CH2 negative, CH3. Second question. Third question. Fluorine. Fourth question. Fifth question. Now just pause the video and try to answer by own. We're gonna solve more question, but for now just try to pause the video and solve these 5 questions by your own. Now let's solve very first question. Now order here minus H plus H minus I plus I. 1, 2, 3, and 4. Next we have here the second one is anti-aromatic, first is non-aromatic. Third we have chlorine minus M effect, we have fluorine minus I effect over here. So the chlorine is more dominating. And we have CH3NO2 and chlorine we remember plus M minus M or minus I. These 3 we have, but the chlorine has more dominating minus M over here, particularly when we compare within the halogen, we consider the minus M for the chlorine specifically, that we have talked about already. Now we have this effect because NO2 is now out of the plane, now it is not able to resonate, it is not showing to minus M effect, but here it is showing minus M effect, so it will be stabilizing. There is no resonance, second one has resonance, so this is the more stable. Now let's solve some more question. Negative charge, negative charge, negative charge, and here we have negative charge farther away, and here we have negative charge like that. Here we have negative charge state. Here this is the resonance again. So sp2 hybridized and sp3 hybridized the carbon ion by removing the hydrogen. As ninth question we have CH2 negative. We have on both the side NO2, both are showing minus M effect, and here we have CH2 negative and NO2 is on the para side. So we know this the 2 NO2 minus M is more dominating than the single NO2 minus M. Now 10th question, CH2 minus NO2, and here we have CH2 minus NO2. We know both are showing minus M. It is showing minus M. It is also showing minus M. But minus M of CH2 negative, second one is more because minus I is more because it is closer and first one is farther. So answer will be this. Right now, just I am in next now. Just I am just writing some questions, and you have to answer it by your own. Right? That is more important that you solve by your own. So we have done the 10 question. Now remaining question I am giving to you. 11th question. CH2 negative CH3. CH2 negative CH3. 12th question. CH2 negative CCl3. Next. CH2 negative CCl3. 13th. CH2 negative CH3. CH2 negative CD3. CH2 negative CT3. 14th question. CH2 negative CH3. CH2 negative CD3. CH2 negative CT3. 15th question. CH2 negative C double bond OH. CH2 negative N double bond O2. 16th question. CH2 negative C double bond OH. HC double bond O. CH negative C double bond O. H. Now we have to compare the stability. Now if we compare the stability, first 11th question. Now in 11th question it is showing CH3 is showing plus H, it is showing plus H, but here plus I is more and here plus I is less. Plus H doesn't depend on the distance because it is completely transfer of electron. So this is the stable. In the 12th case we have here plus minus H and we have plus minus H. Minus I, minus I. So second one CH3, CD3 and CT3. So this is the stability because CH3 has CH3 has more plus H. Wait a second. Stability of carbanion will be reversed because here it is plus H is more and plus H is less. So plus H is the destabilizing effect. CH2 negative CD3 here plus I. Plus I plus I. Now this is the order. This 1, 2 and 3. Now 15th question. We have NO2 has more minus ions compared to COH because nitrogen has more pulling power. And in that case we have two times resonance is single time resonance. So this will be the more stable. So that's how we compare the stability of carbanion. Again the carbanion stability, these factors are important. These 10 questions, these 10 systems are important, very important while considering the problem of stability of carbanion.